Okay, today's lesson we're going to solve simultaneous equations, and both equations will be linear. That just means there isn't an x squared or something like xy. Okay, first question. So the way that I recommend that you do this is pause the video, have a go by yourself, and then return to the video and see if you've got the same answer as me, if you've done it in the same way. Okay, so welcome back. So both of these equations are linear. They've got an x and a y. There's no x squared or anything like x times y. So if you were to draw those, you'd get straight lines. Okay, so 5x plus 3y is equal to 41. 2x plus 3y is equal to 20. Now, really good practice is to label the equations. I've labelled them 1 and 2, and then to tell the examiner what you're going to do. So I'm going to subtract 2 from 1. So take 2 from 1. Okay, so I'm basically subtracting down, and the reason I've done that is because 3y take away 3y is going to eliminate the 3y. So 5x take away 2x is 3x, 3y take away 3y is 0, and that's what I wanted. And then 41 take away 20 is 21. We only have one letter now, one variable in the equation, so we can solve that. So x is equal to 7. Now I want to find the value of y. I'm going to use equation 2, I think. So use equation 2. So that equation is 2x plus 3y is equal to 20. Now I've got a value of x is equal to 7. So 2 times 7 plus 3y is equal to 20. So take away 14 from both sides to give us 6. And y is equal to 2. So I've got x is equal to 7, y is equal to 2. Now I can check to see if that's actually correct by putting it back into the other equation. So I used equation 2 here, so put it back into equation 1. This is equation 1 here, and to see if that works. So I think x is 7, so 5 times 7, add 3 times 2, so that's 35, add 6, and it does equal 41, and effectively means that you can mark your own work. Solve the simultaneous equations. I'm going to write them out. 5x plus y is equal to 11. I'm going to label that equation 1, and 3x minus y is equal to 9. I'm going to label that equation 2. Now notice that these two have opposite signs. One's positive 1y and the other one's positive negative y. So if we were to add these together, so I could say that, so I'm going to do 1 add 2, then I will eliminate the y. So 5x plus 3x is 8x, y add negative y is 0, and that's what I wanted. 11 plus 9 is 20. And that gives us x is 2.5. Now I want to find the value of y. I can use any of the equations. Why don't I use the second equation? So using equation 2 and the value of x of 2.5, so 3 times 2.5 minus y is equal to 9. Now 3 times 2.5. When you multiply by 2.5, you're doing 3 plus 3, and then add a half. So that's 6, 7.5. So 7.5 minus y is equal to 9. I'm going to solve this like this. Add y to both sides, then subtract 9 from both sides to give negative 1.5. So get negative 1.5 for y, and x is 2.5. Just going to check that that in fact does work by putting that into equation 1. So 5 times 2.5 add negative 1.5. Let's see what that equals. So 5 times 2.5, so that's 5 plus 5 plus 2.5, so that's 12.5 minus 1.5, and that in fact does equal 11. Okay, this is a word question. We've been actually asked to set up the simultaneous equation. So let's take the first line here. David buys 2 DVDs and 2 CDs and the total cost is £18. So I'm going to say let D equal the cost of a DVD and C equal the cost of a CD. Okay, so 2 DVDs, 2D plus 2 CDs is equal to 18. That's my first equation. And then LE buys 3 DVDs, 3D plus 2C, and that equals 22. Okay, I'm going to subtract downwards. No, I'm not going to subtract upwards actually. I'm going to subtract upwards. We can go up or down as long as we're consistent. So 3D take away 2D is 1D. 2C take away 2C is 0. That's why I subtracted. And then 22 take away 18 is 4. So D is equal to 4. I want to find the value of C. I'm going, if that was equation 1, that was equation 2. I'm going to use equation 1 here. So D is 4, 2 times 4, add 2C is equal to 18. 8 plus 2C is equal to 18. Subtract 8 from both sides, and then divide by 2, and that gives me C is equal to 5. So a DVD is £4 and a CD is £5. Does that make sense with this equation here? 3 DVDs, so 3 DVDs, that will be £12, and 2 CDs would be £10. Does that equal 22? Yes, it does. Okay, so we've got a little bit more work to do on this one. I'm going to label this equation 1 and this equation 2. So I'm going to write that out there. Okay, I'm going to multiply equation 2 by 4. Okay, so I'm going to keep equation 1 the same. We're going to multiply, so I'm going to multiply equation 2 by 4. So 3x times 4 is 12x. Negative y times 4 is negative 4y, and 4 times 4 is 16. The reason I multiply by 4 is because I wanted this to be 4 as well, because then we can eliminate the y's. Now this is a positive 4y, this is a negative 4y, so the way to eliminate that is to add them together. So if we add, we get 14x, 0y, which is what we wanted. 26 add 16 is 42. Divide both sides by 14, and that gives us 3. So x is equal to 3. I'm going to put that back into equation 1. So we get 2 times 3 add 4y is equal to 26. So that's 6 add 4y equals 26. Subtract 6 from both sides, and that gives me y is equal to 5. So I think x is equal to 3, y is equal to 5, and we can check that back into this original equation here. So I think x is 3, 3 times 3 minus 5, 9 minus 5 does equal 4, so now I've got it correct. Okay, this is probably one of the most tricky types, in that we're going to have to multiply both equations by something. So I'm going to make both of those equal 6x. So I need to multiply this one by 2 and this one by 3. So I'm going to multiply the first equation by 2 throughout by 2. So that gives us 6x plus 4y is equal to 32. I'm going to multiply the second equation by 3. So that gives us 6x minus 9y is equal to 6. Not the only way we could have done it, but I've chosen to do this. Now, these are both positive 6x, so I'm going to subtract. Okay, so 6x take away 6x is 0, and that's what I wanted. Now, this is 4y, positive 4y, take away negative 9y. So let me just write that there. That's we're doing that, which is the same as adding. So we get 13y, and then we subtract 6 from 32, and that gives us 26. And that means that y is equal to 2. I'm going to put that back into equation 1. So using equation 1, 3x plus 2y is equal to 16. And we're going to use the value of y is equal to 2. So 3x plus 2 times 2 is equal to 16. 3x plus 4 is equal to 16. Subtract 4 from both sides, then divide by 3 gives x is equal to 4. So x is equal to 4, y is equal to 2. I'm going to check that in this one here. So x is 4, so 2 times 4 minus 3 times 2, that's 8 minus 6, and that equals 2, which is the answer we got there. So again, I've got that correct. Again, this is a tricky one in that we need to multiply both equations by something. I'm going to suggest that I multiply this one by 2 and then this one by 3 because I want to get 6x for both of them. Okay, so multiply the top one by 2, 6x plus 10y is equal to 2. And the bottom one by 3, and that's 6x minus 9y is equal to 21. Very similar to the last one. Going to subtract. Subtract 6x, take away 6x is 0, which is what I wanted. And then this next, for the y's, it's 10y minus 9y, minus negative 9y, which is the same as adding. So that's 19y. And then it's 2 take away 21 gives negative 19. So y is negative 1. Going to use that value of y is negative 1 to find the value of x. I'm going to use equation 2, I think, for this one. So 2x minus 3 times negative 1 is equal to 7. 2x minus negative 3 is equal to 7. So that's 2x plus 3 is equal to 7. Subtract 3 from both sides, and x is equal to 2. I'm going to check that in equation 1 there. So x, I think, is 2, and y is negative 1. That's 6 add negative 5, which is the same as subtracting 5, which